Welcome to Tech with SAS. In this video, we will discuss about Saga pattern in microservices. There is a part 1 of this video as well. So in that video, I have discussed the context of Saga pattern, why we need it. So I would recommend that please look that video first because that will set the why we require the Saga pattern. But just in a brief, we need Saga pattern because normally any business transaction is spread across or spans across multiple microservices. So what happens when one microservice fails and how we manage that? So we have also discussed one approach in that video, we can use the two-phase commit, but there are some issues or some pitfalls about it as well. So the solution we need that is basically Saga pattern in microservices. So in this video, we are going to talk about how Saga pattern can be used and why it is used, and then the various types of it, right? So let's start on that. So basically, a Saga architecture pattern help us manage the transaction through sequence of local transactions. So a local transaction is a unit of work performed by the each Saga participant. So every operation that is part of Saga should either be successful or failure. So if any of a transaction which is part of Saga it fails, then we have to run the corresponding compensating transactions and it should be rolled back to previous state. So a transaction is either complete in totality or it is not complete at all. So Saga pattern help us basically to ensure that all the transactions which are part of one Saga or one sequence of microservices to fulfill any business should complete in a sense that it makes sense from business point of view. But even if there is a single failure in any of the participant of Saga, then it should roll back using the corresponding compensating transaction. So it basically also need two principle to perform this. Like it should be idempotent and retriable. So suppose you are not filling like any microservice at first try, but you want to at least try like few 3 4 times, right? So that should be like retriable, and also when you are trying to update or reattempt your transaction, that should not state, I mean, should not change the state of the that your resource, right? So suppose you are trying to insert one row and database, so it should not be like that you are trying or inserting multiple rows when you are retrying. So the Saga pattern in a nutshell, basically having lot of or many participants that perform the local transactions, and they make sure, and this pattern makes sure that the whole sequence is completed in totality or it roll back using the corresponding rollback transactions, right? And idempotency and the retrieval is the main principle behind Saga pattern. So now let us see the Saga pattern flow by using an example like which we also took in the previous video. So suppose you have an application that is to book a holiday for your customer. So you have like a three transaction over there, like book flight, book hotel, or book car rental, right? So and like when you are running this saga of these three microservices, if any of the transactions fails, then you have to run the compensating transaction for that, and you have to make sure that each microservices state or their resources go back to the previous state. Otherwise, resources like database will not be in consistent state. So it helps us to keep our database or resources to be in consistent state because we are doing transactions in a complete manner or not doing it at all and rolling back the transactions which were successful but few participants in the saga were failure, to make sure that data remains consistent. So now let us see the various types of Saga pattern. So there are two types of saga pattern. First is the event-based saga pattern, that is a choreography saga pattern, and second is the command-based or orchestration saga pattern. So let us understand these two saga patterns one by one. So first one is the saga choreography pattern. In this, suppose you have multiple microservices which are part of one saga or one business requirement. Then these microservices talk to each other via messages or events. So, for example, if you have this flight booking service and it gets a request from customer, then it will process and then it will emit a message or event to the event channel that is being listened by the next service, and then it will process that request later on. So basically all these microservices are loosely coupled via the any like messaging framework, where each microservice is emitting a message to the event channel, maybe a queue. Then other microservices which are part of that sequential saga pattern, they are listening into that, and then they are performing their business logic. But if any of the microservices is a failure or there is some issue, then we are going to run corresponding rollbacks, and then each of these microservices are going to revert to the previous state. So broadly, we can say that all the microservices in the this pattern are like basically like loosely coupled, and they talk to each other via messages or events. So second, and like these basically are good for the whenever you have like a new project, right? So you can easily basically create these event channels and these microservices which can talk to each other via the messages or events. Then is also a very good pattern whenever you have like small sagas. So suppose you have a three, four, or five type of a participant in one saga, so it is easy to maintain this type of pattern. But if you have like a complex saga and which has maybe not many microservices, then it might be difficult to utilize this pattern in that scenario. Also, like suppose one service needs something from other service, in that case there's a chance of having a static dependency. So in case that happens, so it will be very disastrous, because that service will keep waiting for another service, and that service which is doing something also waiting for another service. So basically all are like waiting for each other, so it might be like a delay in performance of our this saga pattern. Next, we have a saga orchestrator pattern. In this, we have a coordinator service that is called as a orchestrator service, and this makes sure that all the microservices in the saga basically completes the transaction successfully. But if any of the microservices fails or give any issues or errors, then it also makes sure that the corresponding rollback is run, so that data remains consistent in the underlying databases or maybe resources. So this is like a central component which makes sure that the saga pattern is running properly, and whatever the transactions are happening, they are happening in the sense that they are completed or not done at all. So this is like a good pattern whenever we have complex flows, like we have suppose hundreds or maybe twenties of the microservices. So at that time, whenever we have a component which is playing like a central role in whole managing the whole transactions, so it is easy to make sure that transactions or databases remain consistent. But issue is that when like we have one coordinator or orchestrator, then it like a single point of failure. So there is a trade-off between what we want. So in event based, we have basically loosely coupled microservices talking to each other via events and using the event channel. But in the orchestrator pattern, we have a central component which is managing whole Saga. So yeah, that's it for this video. Thank you very much for watching. See you next time. Please leave any comments or questions if you have, and please subscribe. And thank you for your support.